Okay, so hello, we are the students of Division B, B1 Group 3, and this is a video explaining the different components of the motherboard. The motherboard that we have taken here is the ATX motherboard. So first off, what is a motherboard? Motherboard is nothing but the brain of the computer. So all the critical components of a computer system, which provides the foundation for all the components to work together as a cohesive unit, is placed in the motherboard. So the next question is, where is the motherboard found? It is present in the computer case where most of the important parts are placed. So my name is Hriday Barani, roll number 17, and I'm the group leader, and I'll be explaining the CPU socket part of the motherboard. So first off, what is a CPU socket? CPU socket is a slot which holds the CPU in place. CPU is the primary processing unit of the computer, and which also does the executing information and performing tasks or calculations. Where is the CPU socket present? It's usually present in the center of the motherboard, and it's usually surrounded by the RAM slots or the chipsets. Next, coming to the working of the CPU, it is the main work of the CPU is to provide electrical and physical contact. For the electrical contact, it communicates with each other, with the other components of the motherboard. Um, Next is the components of the CPU. So first off, we have the heatsink mounting holes. So what are those? Those are the mounting holes where you actually place the heat sinks or the cooling solutions, which prevents the CPU from overheating and damage. Second is the thermal paste. Thermal paste, what it does is that it improves the conduction between the CPU and the heatsink. It fills the microscopic gaps between the surface of the CPU and heatsink to provide better heat transfer. Next is the motherboard or the CPU controller. It's responsible for managing the flow of data from the CPU to the system memory. The main functions of the motherboard CPU controller is address translation, memory protection, cache management, and memory scheduling. The third is the CPU retaining plate. What it does is it just holds the CPU in place and provides uniform pressure. And also it prevents the CPU from vibrating when it's performing tasks. Next is the retaining plate lever. Um, the main function of it is to lock it in place, the CPU in place, and also unlock it when it's not in use or when you need to actually change the CPU. And the last part is the second last part is the reinforcement screw. What it does is that it improves the stability of the CPU socket, and it keeps the CPU in place. The last and the most important part in the CPU socket are the socket pins, which are small thin pins at the bottom of the CPU socket. So the CPU perfectly in the grooves, and it stays in place. And and the pins are easily replaceable when they are damaged. Thank you.
My name is Shambad Guzar. My roll number is 18. My topic is chipset. One of the most important component of the motherboard is the chipset. Previously, chipset comprised of major part of the motherboard, and nowadays chipsets are being reduced to a small number. There are two types of chipsets in the motherboard. First one is the north bridge, and the second one is the south bridge. So chipsets, the major function of the chipset is used for controlling the signals to the memory, the data bus, and the address bus. The chipset,
Hello.
chipset is basically connected to CPU, the memory, the PCI, and the AGP. The south chipset lies to the southwards. It is connected to the IDE, the USB, the SATA, and the PCI port. These both chipsets are interconnected so that the data could be flowed smoothly through the
ग्रुपची मीटिंग चालू होती ना म्हणून.
motherboard. The north bridge chipset is comparatively faster than the south bridge as
हा
it connects to the major component that is the CPU
नाही
and the
रोज
memory
नसतो.
and
आमच्या
the
शाळेत
PCI.
ग्रुप बनवलाय.
Uh,
आम्हाला प्रोजेक्ट
if
असाइनमेंट
we
करायचे
want to
असते.
send signal from the CPU to the
मग
USB, then
टाकायला
one must connect through the north and the south. So these both
काय झालं
chipsets are
त्यानंतर
being
करून लागला.
interconnected.
So now my name is Harsh Badgandi. My roll number is 16. So now I'm going to be talking about the topic RAM slots in motherboard. RAM slots or sockets on a PC motherboard are long channels, generally located close to the CPU. RAM, which is also called random access memory, are slots on a motherboard. They have physical slots where RAM modules can be inserted to provide additional memory for a computer system. The RAM slots on on the motherboard are designed to accept a specific type of RAM module. The most common type of RAM used in modern computers is the DDR, whose full form is double data rate, with DDR4 being the latest and the most common type. Each RAM slot on a motherboard is designed to accept a certain speed and capacity of RAM module. So it's important to check the motherboard specifications to ensure compatibility with the RAM you plan to use. Typically, motherboards have a total of 4 RAM slots or 2 pairs when they are dual channel. Some high-end motherboards may contain as many as 8 slots, and in computers there may be multiple motherboards per system, up to 32 slots total. There are a couple of reasons why motherboards come with 4 RAM slots, even if you are not going to use them all right away. First of all, it improves the upgradability as you can always expand total RAM capacity later by adding more memory. Second, it also allows you to have 2 slots per channel. There are run-in dual channel mode. More channels translate to wider bandwidth, offering faster data transfers and much improved performance. It means that two low capacity RAM modules running in dual channel can run just as fast, if not faster, than a higher capacity single module. Having more RAM in a computer can allow it to run more programs simultaneously without slowing down, and can also improve the performance in memory intensive tasks such as video editing or gaming. Thank you.
So coming towards another important component of motherboard, which is BIOS. So BIOS stands basically for a basic input and output system, which is a program a computer's microprocessor uses to start the computer system after it is powered on. So it also manages data, the computer system after it is powered on. It also manages data flow between the computer's operating system, OS, and attached devices such as the hard disk, video, adapter, keyboard, mouse, and printer. The term BIOS was first coined in 1975 by American computer scientist Gary Kildall. It was incorporated into IBM's first personal computer in 1981, and in the years to come gained popularity within other PCs, becoming an integral part of computers for some time. In 2017, Intel had announced a plan to retire support for legacy BIOS systems by 2020, replacing them with UEFI. So the main uses of BIOS is to act as a middleman between operating system, OS, and the hardware they run on. BIOS is theoretically the between the microprocessor and I/O devices, control information and data flow. Although in some cases, BIOS can arrange for data to flow directly to memory from devices, such as video cards that require faster data flow to be effective. Uh, so the coming towards the working of BIOS. So BIOS comes included with computers as firmware on a chip on the motherboard. In we could see means the BIOS on the screen presented. In contrast, on OS like Windows or iOS can be pre-installed by the manufacturer. BIOS is a program that is made accessible to the microprocessor on an erasable programmable read-only memory, which is also known as EPROM chip. When users turn on their computer, the microprocessor passes control to the BIOS program, which is always located at the same place on EPROM. When BIOS boots up a computer, it first determines whether all of the necessary attachments are in place and operational. Any piece of hardware containing files the computer needs to start is called as a boot device. After testing and ensuring boot devices are functioning, BIOS loads the OS or key parts of it into the computer's random access memory (RAM) from a hard disk or discrete drive, the boot device. The four basic functions of BIOS are as like. First one is power on self-test, which is also known as POST. This tests the hardware of the computer before loading the OS. Second one is bootstrap loader. This locates the operating system. Third one is software or drivers. So this locates the software and drivers that interacts with the OS once running. The fourth one is complementary metal oxide semiconductors, also known as CMOS setup. This is a configuration program that enable users to alter hardware and system settings. CMOS is the name of BIOS non-volatile memory. So that's all from my side. Now the last part of power delivery is going to be covered by my groupmate Bhushan.
Bachevar and my roll number is 13. So my topic is power delivery in motherboard. So the motherboard receives power from the power supply unit PSU and distributes it to various components such as the CPU, GPU and RAM. The process of power delivery is managed by the motherboard's power delivery system, that is PDC, which includes components such as voltage regulators, modules, inductors, capacitor and MOSFETs. The PDC ensures that the component receives the correct amount of power and that the power is stable and reliable. It does this by converting the voltage from the PSU to the appropriate level for each component and regulating the current flow. The PDC also monitors the temperature of the components and adjusts the power delivery accordingly to the prevent overheating and damage. The power delivery system of a motherboard is crucial component for system stability and performance. A poorly designed or inadequate PDC can cause voltage fluctuations, overheating, and the even component failure. Therefore, it is essential to choose a motherboard with a robust and efficient power delivery system that can handle the power requirements of the components you intend to use. Thank you. The PDC of a motherboard is responsible for regulating the voltage and current that is supplied to the various components of the computer, such as the CPU, GPU, and the RAM. Each component has different power requirements, and the PDC must ensure that each one receives the correct amount of power to function correctly. The voltage regulator modules VRMs are one of the most critical components of the PDC. They convert the high voltage DC input from the PSU to the lower voltages required by the various components of the computer. The VRMs also regulate the current flowing to the components, ensuring that it remains within safe limits. The VRMs are often equipped with the heat sinks or fans to dissipate the heat generated by the conversion process. Inductors and the capacitors are also essential components of the PDC. Inductors store energy in a magnetic field, while capacitors store energy in an electric field. These components help to smooth out the voltage and current fluctuation that can occur in the PDC, ensuring that the power supplied to the component is stable and reliable. MOSFETs, metal oxide semiconductor field effect transistors, are another critical components of the PDC. They act as switches that control the flow of current to the components. MOSFETs are used in the combination with the VRMs to regulate the voltage and the current flowing to the components. The PDC of a motherboard is designed to handle a specific amount of power, and it is essential to choose a motherboard that can handle the power requirements of the components you intend to use. A robust and efficient PDC can ensure stable power delivery, which can lead to better system stability and performance. On the other hand, an inadequate or poorly designed PDC can lead to voltage fluctuations, overheating, and component failure. Therefore, it is essential to pay attention to the quality of the PDC when choosing a motherboard for your computer. Thank you.
Myself, Harsh Bacha, roll number 14, and I am going to explain expansion slots. So the model of CPU which we have used is ATX, Advanced ATX, which is stands for Advanced Technology E Extended. Is a motherboard from factory specification that was introduced by Intel in 1995. The ATX specification defines the layout, dimension, and power supply requirements of a motherboard. The extendable port is an expansion slot that is found on an ATX motherboard. Type: the standard ATX extendable port is a PCI, Peripheral Component Interconnect Express slot. PCI is an high-speed serial computer expansion bus standard that is used for connecting peripheral devices to a motherboard. The size of the standard ATX extendable port is a full-length PCI slot, which means it is a 145.5 centimeter, that is 7.5 inches long. The ATX motherboard can have several PCI slots, typically ranging from 1 to 7 or more. The number of slots depends on the specific motherboard models and is intended use cases. PCI slots are compatible, which means that a PCI slot 3.1 device can be used in a PCI 4.0 slot and vice versa. However, the device will only operate at a maximum speed of the slot. The PCI slots are classified by the maximum data transfer rate, measured in gigabytes per second. The standard ATX extendable port is typically a PCI 3.0 slot, which has a maximum transfer rate of 8 Gbps per lane. The full-length PCI 3.0 slot has 16 lanes, which gives it a maximum transfer rate of 128 Gbps. The ATX extendable port is used for connecting expansion cards to a motherboard. Expansion cards are used to add new functions to a computer system, such as graphic card, sound card, or network card. Overall, the standard ATX extendable port is a key feature of ATX motherboard, allowing for easy expansion and customization of computer system. Expansion slots on motherboard provides a way to connect various types of expansion cards or peripheral to computer systems. These slots allow the addition of new capabilities or upgrades to the computer system. The expansion slots are typically located near the edge of the motherboard and are usually covered by removable metal brackets or plastic covers. The type of expansion slots on motherboard determines the type of peripheral or hardware that can be added to the computer system. The most common type of expansion slot are PCI, PCIe, AGP, and ISA. So PCI already explained. PCIe also I explained. So AGP is accelerated graphic port, is a specialized type of expansion slot that is provided that provides faster data transfer from the older PCI slots and supports advanced features such as 3D rendering and video acceleration. AGP slots comes in different versions. They include 1.0, 2.0, and 3.0, each with different speed and capability. ISA stands for Industrial Standard Architecture. This is an older type of expansion slot that was once common but is now largely obsolete. It supports 8-bit and 16-bit data transfer and operate in a frequency of 8 megahertz. They were used for adding expansion cards such as sound card and modems and serial ports. Thank you.